I'm Mike Galley. Thanks for watching. If you want to stay connected for more engine power, just click the subscribe button below.
We found this 302 small block Ford hidden away in the corner of the building. We don't know anything about it, but we're going to fill it with parts we've got lying around the shop and see what happens.
Hey everybody, when Pat and I got to the shop this morning, we had to switch gears on a project we originally had planned because we're waiting on parts for it. So we took a little walk around our shop and found an engine that was stashed with all the others. Now we really don't know anything about it except it came from one of the other projects in the other shows, and it seems to have very little runtime.
Being it's just a short block, we need some parts to get this engine running. So we searched around on the shelves and we think we have enough parts to get it together and maybe even do a little bit of tech with some different intake manifolds and camshafts. So we decided to call this Scavenged Small Block Ford.
Some of these parts are leftovers from other projects that were not used or new parts that have been floating around for a while. We're not going to get everything done today, but here's what we will be doing to this engine over time. It will get a couple different flat tappet camshafts. We'll show the difference between a standard manifold and a high rim, which we are excited about, and even swap out a carburetor for EFI. This engine has a little something for everyone, even if you are not a Ford guy. It's all tech that can be used on any engine.
This block's casting number is an E7TE, making it a 1987 model. It's been bored and honed 40 thousandths over and has a cast piston that is 28 thousandths in the hole. It turns over nicely, and by looking at it, we think it has only been started and ran for a couple of minutes. It's missing some crucial components like the camshaft, valve train, and the rest of the induction. So let's get it together so we can start some dyno time. Having one that you don't know anything about, to me, is kind of fun.
Yes.
It's kind of like the FE was like that. The 300 was like that.
The 5.3 LS we got.
The 5.3 LS was like that.
Yeah.
You don't know what's been done. This one has ran for like, I don't know if it was ran for.
That's what puzzles me about it.
It ran. Now it's apart, and it's got.
This is how clean it was when.
This was some sort of either crate engine. I don't know what it is. All right.
There's not much oil in the engine, but the little that's in there looks good. The rotating assembly turns over easily with no binding or interference. Another good sign.
We're going to scrape off the gaskets, blow out the debris, clean the cylinders with some lacquer thinner, and continue with the build.
We're using what we have, so that's why we're running a flat tappet camshaft. This first one we will use is for a Windsor and is pretty mild. It has 213 degrees of intake duration and 219 degrees on the exhaust at 50 thousandths lift. Lift at the valve with the 1/6 rocker arm is 483 on the intake and 499 on the exhaust. Lobe separation angle is 112 degrees.
A factory cam retaining plate keeps the cam in place. This timing set was in an oil pan in our parts cage. After a little searching, we found out it's a Summit Racing heavy-duty double roller with an iron gear and sprocket. It is not adjustable. The cam was degreed and it comes in at 105.5 degrees intake centerline, which is 6.5 degrees advanced. Remember, it has a 112 degree lobe separation angle. The pan that we removed was not the correct one for the pickup that is bolted to the oil pump. So a bonus scavenger hunt ensued, and it led us to the correct Canton pan. It has oil control baffles and a built-in crank scraper.
Before it goes on, the timing cover needs to be installed. Now a Canton one-piece oil pan gasket is laid down. It has compression stops to ensure the pan is not over-tightened. Finally, we can seal up the bottom end by setting the pan on the block's pan rail. Our go-to fasteners will cinch it down, none other than ARPs. We had some good gaskets on one of the parts shelves and a set of inexpensive aluminum heads. The gaskets are our favorite, Cometic MLSs. These have a 27 thousandths compressed thickness and a 4/155 bore.
The cylinder heads are made by Flowtech. They are designed for entry-level street performance. These are the 180cc intake version. They have a 58cc combustion chamber and a 62cc exhaust port volume. Valve sizes are 1,940 on the intake and 1,550 on the exhaust. You can get a set for less than $900 for the pair at Summit Racing. We even flow tested them, and Flowtech's numbers are accurate. A spark plug is a spark plug, right? You wait and see.
How to check pushrod length is the subject of today's tech tip.
Pushrod length is critical to valve train geometry. Things like rocker arm type, block height, milled cylinder heads, longer valves, and camshaft base circle can alter pushrod length from factory dimensions. TrickFlow's Pro calibrated pushrod length checkers are among the most accurate available. Each full rotation equals 5/100ths of an inch of length. Grooves are placed every 5/100ths of an inch on the inner sleeve, and a laser-etched alignment line on the body identifies the position of each rotation. Here's an example of using a Pro-calibrated pushrod checker that measures length from 6.8 inches to 7.8 inches. Twist the checker apart one full rotation. The length increases to 6.85 inches. TrickFlow Pro-calibrated pushrod length checkers are available in multiple length ranges.
We're in the Dyno Room to revisit a cool little build we did a while back. Now, it was a true salvage yard refresh using minimal parts to bring a worn out engine back to performance level potential. Now, we ball honed the cylinders, replaced the lifters, the camshaft, and the main bearings only. Then, we strapped it to the dyno. With the dual plane manifold and carburetor bolted up, here's the results of our low buck Vortec refresh.
According to what you might read on the internet, the stock LS short blocks are good to around 1,000 horsepower, so we thought it would be fine to spray it to lay down some big power and torque numbers. Here's what happened.
We're going to use this engine as a test bed to do a little scientific testing. Now, we want to see if we can pull more power and efficiency out of this engine by changing 8 small parts that don't involve cracking it open.
For the last few years, we've had the same battery installed in our dyno room, and what it does is power all of our 12-volt sources, like our starter, our ignition box, and our switched and constant 12-volt power sources. But like everything else, a battery has a service life. So before we get started today, we are going to install a new one. The Duralast name comes to mind when it's time to buy a new battery. They have a bunch of different applications for different purposes, and this ProPower AGM is a beast. AGM stands for Absorbed Glass Mat, and this battery is designed to provide big starting power. It has advanced technology for vehicles with accessories that demand greater power. Another feature it has is deep cycle capabilities. It also cycles more and recharges faster. It has 2 times the cycle life of a conventional battery. This one has 850 cold cranking amps at 0 degrees and 1,000 at 32 degrees. Since we need a marine-style terminal for the dyno connections, we decided to order this Duralast Marine starting battery. It has 1,000 cranking amps as well, and will give us years of worry-free service just like the last one.
Now it's time to get started with the testing. Finding the power and efficiency I mentioned earlier will be based strictly on changing the spark plugs. Now, for the baseline pulls, we're going to run a factory replacement AC Delco plug, so let's get started.
Now, this engine currently has 30 degrees of ignition timing, and it's running on 93 octane pump gas. But we did change out that dual plane intake for a single plane one and topped it off with our QFT Black Diamond 950 CFM carb. So it's time to listen to this thing make some power. Look at that, 399.9. I'm gonna go ahead and call that 400.
I would give it that.
That's nice and smooth.
Good torque.
Good everything. Look at how smooth the graph is.
Beautiful graph.
All right, well, that's
let's back it up.
Oh, it actually made a little bit more. 403.
Broke the 400 mark.
Wow, must have got a good molecule of air go through it.
All right, I say that's a very good starting point.
Yeah.
For what we're going to do. That's the AC Delco stock replacement plug.
Right.
Now we're going to put an E354 in this thing.
Yep, and we're going to see what it does. Now, You know, with the diamond fire technology, hopefully it'll increase a little bit of combustion efficiency, might make a little bit more power. The efficiency is the big deal. It's how much fuel it uses. If it uses less fuel, makes the same power, it's more efficient combustion.
Here's a look at a cutaway E3 plug, the plug that's going in next, and the AC Delco we just made poles with. Notice the ground strap design on the E3 compared to the AC Delco. The E3 plug utilizes a patented edge-to-edge electrode, which is the best way to direct a spark as it leaves the electrode surface. The results are better combustion for more efficiency, which should result in more power. Let the second part of the test begin. Well,
Oh,
look
okay.
at that.
390, 408.
408.
408 for peak. Wow. I'll tell you the truth, that's more than I expected, right?
That is impressive.
Before we look at anything else, make one more run just to verify that number. And well,
If that's the case, I'm going to buy a set today and put them in my truck.
yeah, 406, 390, okay.
It's legit.
I'll take that. That's 100% legit.
Back-to-back runs. All right, I'm gonna shut this thing down. Let's look at some data. With the AC Delco plugs, the Vortec averaged 401.5 horsepower and 382.5 pound-feet of torque. With the E3 plugs, the average was 407 horsepower and 390 pound-feet of torque. That's an average gain of 5.5 horsepower and 7.5 pound-feet of torque with the E3 plugs.
Average fuel consumption in pounds per hour was almost identical with the AC Delco and E3 plugs. But since the E3 plugs made noticeably more horsepower and torque, they clearly have better combustion efficiency.
We used nitrous on this engine before, and we want to do it again. We're installing Holley's Sniper nitrous system and put the 210 horsepower jets in. We're installing some colder range E3 108 plugs to accommodate the extra cylinder pressure. Since we're going to have some fun with nitrous, we want to make sure we have excellent fuel to avoid any issues. So we're going to mix some of our 93 octane pump gas with Race Gas Ultra, which is an additive that will increase the octane rating by full points. Race Gas Ultra is designed for high compression, boosted, or nitrous engines. When mixed with pump gas, it will create a 108 to 112 octane race fuel. Not only does it increase the octane, it also increases the chemical oxygen and chemical energy to equal commercially available distilled race fuels. It's being mixed to create 112 octane race fuel, so we will pour in 1 can in 4 gallons of 93 octane pump gas.
Oh, 633 horse, 726 pound-feet of torque.
Dude, this is a true junkyard refresh.
Yee!
I don't like making poles on this thing that way with the nitrous. I just don't like being the guy pushing the lever.
I like you being the guy. To make sure we didn't hurt this junkyard Vortec with the big shot of nitrous, we made several NA runs. The engine performed flawlessly. Up next, the small block Ford gets a new valve train and induction. Then we see just what this mystery engine can do. We're continuing the build of our 302 small block Ford, focusing now on the valve train. These are stock replacement hydraulic flat tappet lifters, which are installed after they're coated with camshaft-specific break-in lube. The lube helps the cam and lifters establish the correct break-in pattern. When installing the lifter, make sure the bore is clean and the lifter is free to rotate. The push rods are comp chrome moly ones with a 5/16 diameter, 80 thousandths wall thickness, and a total length of 6,750. Finishing up the valve train is a set of 1.6 ratio roller rocker arms. The valve adjustment is 1/2 turn past 0 lash. To seal the intake manifold, we're using Permatex The Right Stuff 1-minute gasket maker. Unlike other products with a 24-hour cure time, it lets you return your engine to service immediately. The intake manifold is a Wyand Street Warrior dual plane that was in a pile of old parts. It's a solid choice for a street machine setup. A set of cast aluminum Ford Racing tall valve covers seals everything up. We found them next to the short block and thought they looked racy, so on they go. Keeping the water circulating is our Meziere electric water pump. It's a mainstay in our dyno cell. Now we're off to the cell block, where we'll complete the engine with everything to get it running, which includes our 750 CFM Holley Brawler dyno carb, an MSD Pro-Billet Distributor, MSD's 8.5mm superconductor wires, along with purple wire separators for a touch of panache, and TrickFlow 1 7/8 primary mid-length headers. Because this engine has a flat tappet camshaft, we have to do a break-in cycle with it. Normally you don't have to do that with a roller cam. This one's a flat tappet, so we have to run the engine, has to start immediately and vary the RPM between 2,500 and 3,500 for around 15 minutes. That establishes wear patterns on all the parts, and then we will drain the oil, check the filter, and then we're ready for some dyno. But first, we do have to break it in. Our Superflow Power Mark has some extraordinary capabilities, like having a break-in cycle where we can program the engine to run in our specified range for however long we want. We did 2 sets of 50 cycles between 2,500 and 3,500 RPM at partial load. Then we drained the break-in oil and checked it and the oil filter for any sign of engine damage, like debris or water. Looks clean. Up next, we have some fun in the dyno cell. Plus, we clear up a common misconception about carburetors. All right, we are all systems go to start making some pulls. Now what we're gonna do is I'm gonna start at 30 degrees timing. I'm gonna go from 2,500 to 5,500 at 600 RPM second to see if it keeps its guts. Chunky. 335 pound-feet of torque at 3,800, not bad. 297.9 horsepower at 5,300. After some more pulls and some timing adjustments, we ended up at 36 degrees total timing. Condensation on the outside of the carburetor is normal. It stems from the cooling effect of the fuel passing through the venturis. 337 pound-feet of torque and 323 horsepower, that's decent. I figured this one would make in the mid-320s with that cam, so should be interesting to see what it does with a different one. Our second hydraulic flat tappet cam is definitely more on the racier side of the street. Duration at 50 thousandths lift is 234 degrees on the intake and 244 degrees on the exhaust, with 114 degrees of lobe separation. Lift with a 1.6 rocker ratio is 520 thousandths on the intake and 542 thousandths on the exhaust. Our cam was installed at 112 degrees of intake centerline. Anytime you install a new flat tappet cam, new lifters are a must. All right, we're all broke in. The timing is right back to where it was, 36 degrees, so this is a direct cam comparison. Dropped a little bit of torque and dropped a little bit of power, which, not surprising. 313 for horsepower, 318 for torque. Now, this is pretty interesting. It starts to flatline up top for whatever reason. Now, that could be a whole bunch of different things, right? That could be valve spring, that could be intake manifold, because we have a larger cam that's not as advanced as far as where it's degreed in. The smaller cam traps air earlier, it's gonna make more torque. This cam is more suited for a better manifold, which we're not going to put on right now. But what we can do, let's put our Racy 950 on and just see what it does. And we're going to pull it to the same RPM, and we're going to go from there.
Perfect. Let's do it.
All right. The carb swap will increase the cubic feet per minute by 200. But this brings up a common misconception about running a carburetor that is considered too big.
Pat, isn't that going to flood the engine?
That is not how that works. CFM doesn't flood the engine.
No, it doesn't.
Too much fuel floods the engine, but just because you have a larger carburetor on does not mean it's going to flood the engine. And that's what you have to understand about how barometric pressure works and how your Venturi works, how everything that's the carb has in it is set up. All right. Yeah, figures as much. How about that? A larger cam that is installed not as advanced as a smaller cam will not build cylinder pressure in the lower RPM. That way it works with this dual plane manifold a little bit better. Where this other cam, which is bigger and racier, where it wants to run, it runs out of manifold. And and you can put a bigger carburetor on it. It didn't flood it. You know what it did? It made more power. So this now intrigues me to do even more to this, put a manifold on it. We need to get some sort of single plane manifold for it. We'll start there. And maybe even like do a different ratio rocker or something.
Yeah,
but,
absolutely. Success.
It's success. I don't know what we learned, but it was fun.
It was success.
If we can dyno engines, it's fun and it's a success, especially if nothing comes apart.
That's right. For more information on today's show, check out our website, PowerNationTV.com.